Good day, everyone. My name is Dr. Oluwafemi George from the Department of Systems Engineering, University of Lagos. In this series titled Engineering Algebra I, I'll be talking about axiomatic set theory, Boolean algebra, switching circuits, transfinite induction and recursion, monotonic sequences and convergence, Cauchy criteria, power series, and operations on power series with some worked examples. Now, what is axiomatic set theory? Axiomatic set theory is a fundamental discipline within the field of mathematics that is concerned with the examination and analysis of sets, which are defined as assemblages of objects or entities, whereas sets as key components of axiomatic set theory are organized collection of objects or entities. Now, some key components of axiomatic set theory include axiom of extensionality, and this states that sets with the same elements are equal. We have axiom of regularity, and this states that one of the elements of A is a set which is disjoint with A. In axiom of pairing, if you are given two sets, X and Y, there exists a set Z whose members are X and Y. Axiom of union states that elements of multiple sets can be combined into one larger set. In axiom of power set, for instance, let's take a set S. There exists a set S prime that contains all and only the subsets of S. Axiom of infinity ensures the existence of an infinite set. Others are axiom of schema of replacement and axiom of choice. Another important subject is cardinality, and this is defined as the number of elements in a set, either finite or infinite. Now, let's look at the definition of some basic set operations. Set membership. We use the symbol epsilon to indicate set membership. For example, if A is a set whose elements refer to all kinds of fruits, and X is a set containing fruits like apple and orange, we then say X belongs to A, or symbolically as X epsilon A. A set containing no elements or with zero cardinality is called an empty set or a null set. It is denoted symbolically by the two curly brackets. Two sets A and B are equal if they have the same number of elements and the items in both sets are the same. That is, number of element A is equal to number of element B, and items A is equal to items B. Cardinality is the number of elements in a set if every element of set A is contained in set B, then A is a subset of B. Set union. The set of all the elements which can be found in set A and set B, or both the elements in A and B altogether, is referred to as the set union. Whereas set intersection is the set of elements which can be found in both A and B. A set which has elements of all the related sets without any repetition of elements is referred to as the universal set. If A is a subset of the universal set, then A prime is the set of all members of the universal set which are not the elements of A. Set difference, pronounced A difference B or A minus B, is the set of elements in A which are not in B, or B difference A, that is the set of elements in B which are not in A. These joint sets are sets with no elements in common. For example, if A is equal to 1, 2, 3, and B is equal to 4, 5, 6, we say A and B are disjoint sets. Now, let's look at some solved examples. 1. Given the set A equals A, E, I, O, U, determine whether the following letters are not members of A. We have B, O, U, S, and I. Solution. Now, B is not a member of A. Also, O is a member of A. U is a member of A, and I is a member of A. So we have that we have that B, S are not members of A. So let's move to the second question. Consider the universal sets consider the universal set U equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to determine whether set C equals 2, 4, 6 is a subset of U or not. So, solution indeed 2, 4, 6 is a subset of U because so let's look at another example. Consider X equals A, B, C, and Y equals 1, 2, 3, 4. Are the cardinalities of X and Y equal? Solution. The cardinality, no. You say no. Cardinality, the cardinality of X and Y are not equal because X, the cardinality of X is equal to 3 and that of Y is equal to 4. Now, let's take a look at another example. Given M equals 1, 2, 3, 4, determine the cardinality of the power set P of M. So again, solution, the cardinality of the power sets P of M is equal to 2 raised to power M, and that gives us 2 raised to power 4, which is equal to 16. We give us 16. Now, our fifth example, given Q is equal to A, B, C, D, E. Calculates the P of Q, that is the power sets of the power set of Q. So, solution, the power sets of Q is P of Q, and this is the empty set, comma. We have A, we have B, comma. We have C, comma. We have D, comma. We have E, comma. We have A, comma B, comma. We have A, comma C, A, comma C, comma. We have A, comma D, comma. We have A, comma E, comma. We have B, comma D, comma. We have B, comma C, comma. We have B, comma E, comma. We have C, comma D, comma. We have C, comma E, C, comma E, comma. We have D, comma E, comma. Then we have A, comma B, comma C, comma. We have A, comma B, comma D, comma. We have A, comma B, comma E, comma. We have A, C, E, A, comma C, comma E, comma. We have A, C, D, A, comma C, comma D, comma. We have A, D, E, that is A, comma D, comma E, comma. We have B, C, D, B, comma C, comma D, comma. We have B, C, E, B, comma C, comma E, comma. We have B, D, E, B, comma D, comma E, comma. We have C, D, E, C, comma D, comma E, comma. We have A, B, C, D, A, comma B, comma C, comma D, comma. We have A, B, C, E, A, comma B, comma C, comma E, comma. We have B, C, D, E, B, C, D, E, comma. We have A, C, D, E, A, C, D, E, comma. We also have A, comma B, comma C, comma D, comma E. So if we count this number, we see that there are 32 different sets, and that is the power set of Q. Now, for the P, to calculate the P of Q, so this will now give us 2 raised to power P of Q, And this is what give us 2 raised to power 32. And this is our last, the final answer, which is 2 raised to power 32. So, and that comes to the end of this session. Thank you for listening.